Okay, so now in 4-6, we are looking at the rest of the trig functions and how to graph them. This is going to be part 1, and we're going to look at tangent and cotangent. So looking at the graph of tangent first, we're evaluating tangent at these angles. And you'll notice that the angles I'm choosing are different than sine and cosine. And I'll explain in a minute the reason why. But let's just start at 0. Well, tangent of 0 is 0. Tangent of pi over 6 is root 3 over 3. Tangent of pi over 4 is 1. Pi over 3 is root 3. And now we start looking at things that are not on the unit circle. And so I'm just using my calculator to get a decimal. This is about 3.7. This is about 11.4. And this is about 57.3. And if you type pi over 2 into your calculator, you're going to get undefined. Now what we're saying then, if we think about these values, in fact, let's go ahead and plot these values. We're looking at tangent of 0, tangent of pi over 6. Well, this is pi over 4, pi over 6 is about right here. And that was about root 3 over 2. Then we had 1, and then at pi over 3 we had root 3, and then we started getting these really big values. We're noticing that the tangent curve is getting big. I mean, we got 57, 11.4, really big values. But at pi over 2, it's undefined. And the reason it's undefined there is there's an asymptote. Cosine is 0 at pi over 2, and so dividing by 0, we get undefined, and our graph approaches an asymptote right there. Now, what we need to remember about tangent is that it's an odd function. That's on our identity sheet, that it's an odd function, which means it's symmetric about the origin. So what we know about its graph then is that what it has right here, it'll have the same thing down here. So let's go ahead and draw both sides of our graph. At negative pi over 2, we're also going to have an asymptote. Here we have 0, and then at those quarter points, we have 1 and negative 1. So with tangent, we have halfway and we have quarter points, and then we have asymptotes on the end. Now, one of the other differences we'll notice with tangent is that notice that these values go way past 1, and we can see in our graph that it's way bigger than 1, whereas with sine and cosine, it stayed between negative 1 and 1 in between here. Now, sine and cosine are the only ones that stay in between here. The rest of our graphs will have asymptotes and will shoot off to infinity. So this is one period of tangent. Remember that the length of the period is pi. Half pi would be 1 pi here for the length of the period. And I'm going to go ahead and flip the page and look at an example. Or actually, before we look at an example, we're going to go over some more information. I'll zoom in for you here. So notice that this is some information about the tangent graph. We know the period is pi. Looking at the domain, it's all real numbers except odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2. And then the range, the y values, is all real numbers because it shoots off to infinity in both directions. We have vertical asymptotes at odd multiples of pi, just like what we talked about with the domain. X-intercepts is in between, halfway between the asymptotes, and this is an odd function. So this is the general graph of tangent. We have asymptotes here. And this is the shape of the tangent graph. It's 0 midway between, and then quarter points at 1 and negative 1. Okay. So variations of tangent are also something that we can graph. I'll go ahead and zoom back out here. So normally tangents between negative pi over 2 and positive pi over 2. So if you want to see where your asymptotes are going to be, just like we did with sine and cosine, you're going to want to set that up in your notes and then solve for x, just like we did before. And that's what's going to be useful for us here. And then your book, for whatever reason, doesn't write plus D here, but you can add a vertical shift with tangent as well. I'm not going to go over each one of those shifts because you've already seen that twice with sine and cosine. It works pretty much the same way with tangent. So let's look at an example here. It says graph 2 tangent 1/2 x from negative pi to 3 pi. Okay. So the first thing we're going to do is draw our little box over here. And we have absolute value of A, our period, we have our phase shift, and our vertical shift. And we're just going to get in the habit now of writing all 4 of these things. Well, there's nothing added on the end or anything, so there's no vertical shift. And there's nothing added or subtracted in on the x there, so there's no phase shift. And I want you to tell me these. I need to know that you are aware that there are no phase shifts or vertical shifts for these graphs. Now our period, remember for tangent it's pi over b, not 2 pi. So in this case, our b is 1/2. So pi over 1/2 gives us 2 pi. And our amplitude is 2. So we're going to go ahead and graph. Before we graph, we are going to set up where we're starting and where we're ending. So remember, negative pi over 2 and less than or equal to 1/2 x less than or equal to, actually, that's a good point here. There's no equal to because these are where our asymptotes are. So you should just have less than here. And then pi over 2. Well, we want to multiply by 2 everywhere because we want to get rid of this 1/2. So all our fractions here reduce. And negative pi less than x less than pi. And now we can go ahead and mark those as our asymptotes. So we have an asymptote at pi. We have an asymptote, I'm going to zoom out a little bit here, at positive pi. And then we can repeat this again so that at 3 pi, since they want us to graph until 3 pi. Well, graphing tangent's going to be really easy for us now. Halfway between the asymptotes, it's 0. And over here as well. And then our quarter points, well, this is positive, so it starts up and is down over here. So our amplitude is 2, so our quarter point is at the amplitude and negative amplitude. And there we go. And same thing over here. And that's our graph for tangent. Okay. All right. So just one thing I want to point out here. If we had a negative 2 out front, that negative would flip this over. So it would be up over here and down over here. Okay. Let's move on to the graph of cotangent. So I'm not going to use as many values because you've already kind of figured out the pattern of what happens here. But filling these in here, we have cotangent of 0 is undefined. And at pi over 4, it's 1. And at pi over 2, it's 0. And 3 pi over 2, it's negative 1. And then undefined. And these are my 5 critical points here. So let's go ahead and draw exactly what's happening. At undefined points, we have asymptotes. So cotangent has asymptotes instead of at negative pi over 2 and positive pi over 2, it has asymptotes at 0 and pi. And again, our period length is still pi. And then we can go ahead and draw our graph. So halfway is 0. And instead of starting up over here, it's positive at the first quarter. And then third quarter is negative. And the shape of this graph is very similar to tangent. It's just slightly different because tangent, if we look up at the one above, tangent is from negative, is this way, and then it's going positive. Cotangent is running negative, and it's shifted over a little bit. And again, this is one period of cotangent. So let's go ahead and flip the page and look at some more information about cotangent. So cotangent, similar to pi, has a period of, or similar to tangent, has a period of pi. Domain, all real values except for multiples of pi. Range is all real numbers. Vertical asymptotes at multiples of pi. X-intercepts odd function. Again, very, very similar to our tangent function. This is a single period of our cotangent graph. Okay. Now, variations of cotangent, again, works very similar. We have amplitude, period change, phase shift, and vertical shift. And this is the way you'll set it up for cotangent. You'll start from between 0 and pi and then solve for x to find your start and your end. Okay. So let's move on and start looking at an example of cotangent. So we have 3 cotangent to x, and you know what, why don't we add it, well, we'll leave it at 3, never mind. So first thing we want to do is set up our box, and we're only graphing one period. My amplitude, period, phase shift, and vertical shift. Well, there's no vertical shift, there's no phase shift. There is a period change, so pi over b is going to be pi over 2, and we do have an amplitude of 3. So there's that. Now we want to set up where we're starting and where we're ending. So we have 0 less than 2x less than pi, and dividing by 2 everywhere, we have 0 less than x less than pi over 2. So this is our start, this is our end. So we're starting here where our asymptote is at 0, and our end is at pi over 2 where our other asymptote is, and cotangent in the middle is 0. First quarter is at the amplitude, second quarter or third quarter is down, and that's our cotangent graph. Very similar to graphing tangent. And I'm going to end the video here, and then we'll pick up with cosecant and secant.